So next we will see about the instruction sets of 8085 microprocessor. The instruction sets are nothing but the set of commands that we use to write the program for 8085 microprocessor. There are 5 sets of instruction sets in 8085 microprocessor, which is nothing but 5 groups, 5 different groups that we use for write the program. The first group is data transfer instruction set, and second one is arithmetic instruction set, third one is logical instruction set, fourth one is branch instruction set, and fifth one is machine control instruction set. So we will see one by one about these instruction sets. The first instruction set is data transfer instruction sets. The data transfer instructions are used to transfer the data between two locations. The location can either be register or memory. So the possible data transfers are, you can transfer a data between two registers, a data from one register to another register, or else you can transfer a data from a memory to a register, or vice versa, register to memory. But the only not possible combination is memory to memory. You can't perform memory to memory data transfer. It is possible only to transfer memory to register, register to memory. So we will see one by one the data transfer instructions. The first instruction that we are going to see is move immediate instruction. So this instruction, actually the general format, instruction format is, you have to write the mnemonics, then destination, and then the source. So mnemonics are nothing but the operations to be performed. So destination where your data has to move on, and source where you get the data. So when you compare this here, MVI is nothing but a mnemonic, R is a destination, and data of 8-bit is a source. So mnemonic MVI is nothing but move immediate data. So here R represents a register, that to 8-bit register. Since you are transferring 8-bit data, it's an 8-bit register. Data is your input value. So what this instruction will do is, it will move the 8-bit data to the register that we have mentioned in the instruction. For example, if you take this move immediate A, 85, here 85 is the input data, which is nothing but the operand of 8-bit, will be moved to the accumulator. So before execution, accumulator will have some other value, 54 or something. After executing this instruction, so 85 value will be moved to accumulator. This value will be replaced by 85. So the next instruction is move immediate m comma data. So here you are transferring the 8-bit data into a register. Here you are transferring the 8-bit data into the memory location. So if you want to move a data, for example, MVI m comma, take the same value 85. If you want to move this 85 value to the memory location 2450, this is the memory stack 451. Okay, if you want to move this 85 to this location, you have to store this 2450 into the register pair HL. So this register pair HL is mentioned here as M. So what this instruction will do is, once the processor sees and execute this instruction, it will see to the HL register pair to know what's the value stored in it, and then it will transfer to that location. So now you want to move this 85 to the location 2450. So you have to store this 2450 value in HL register pair. The processor sees to this HL register pair what's the value stored in it. So it will see to this and take this as a location and move this value to 2450. So while storing this value, how it will be stored is 24 is the higher byte, 2450. Okay. So 24 is the higher byte data, it will be stored in H register. 50 is the lower byte data, it is stored in L register. So the next instruction that we are going to see is move B comma A. So this is our destination register and this is our source register. The general format will be like move RD comma RS, source register, destination register. What will happen here is the value in A register will get stored in B register. So before executing this instruction, A register will have a value of 45, B might have the value of 66. After execution, what will happen is the value in A register will get stored in B register. So B, now it will have the value of 45. What the A register will have? It will also have 45. The operation that is taking place here is just copy and paste. The value in accumulator will not get vanished. Okay, it is just copied. So the next instruction that we are going to see is LDA address. So LDA is nothing but load accumulator. So what operation will take place here is, so here we have mentioned as address. This address is nothing but a memory location. So I will explain you it with an example. For example, LDA 5645. So this is a memory location. So this would be your stack memory. So consider this 45. This has 5646. This has 5647. Okay. So load accumulator in the sense the value in this memory location will get stored in accumulator, which is nothing but the value in the memory location. Value of that address will get transferred to the accumulator. For example, 5645 will have the value of 46. So before execution, 5645 is having the value of 46 and the accumulator is having the value of 49. After execution, the accumulator value will be replaced with 46 and the memory location will be retained with the same value. So what will happen here is the address location having some value which will be stored into the accumulator when we use the load accumulator instruction. So the next instruction is store instruction. STA address. So here your store accumulator. So example for this is STA 55FC. So this would be the memory location. Okay. So 55FC, 55FD, 55FE. So these are all the hexadecimal values which I have already told you. Okay. See, the address values are hexadecimal values, not decimal values. Fine. So what will happen here is the value in accumulator will get stored in the memory address mentioned in the instruction. Okay. So as of this instruction, what will happen? The value in the accumulator will get stored in the memory location 55FC. So for example, before execution, if you are having a value in the accumulator as 5A, okay, in the location 55FC, you might have the value of 5F. So after execution, what will happen? The A will be retained with the same value 4A, but this stack 55FC will be replaced with the value in the accumulator, that is 4A. Fine. So the difference between load and store is that load, it is from memory address to accumulator. Okay. So here in store, the value in accumulator is stored in memory. Okay. In both these two instructions, only accumulator register is used and not the other registers. So for load and store instruction, the accumulator register is only used, other special purpose registers and general purpose registers are not used. The next instruction is load immediate 16-bit value. So the first instruction that we have seen is MVI A,85. So here we are transferring an 8-bit data immediate, that to an immediate 8-bit data to an accumulator. So in other case, if you want to transfer a 16-bit data to a register, you are supposed to use load immediate. So for example, if you want to move a value 4A 6E into a register pair DE. So why we are using register pair? So it's a 16-bit value which will be stored only in a 16-bit register. Each and every register is an 8-bit. Totally it is a 16-bit register. So if you want to move this 16-bit value into a register pair, I have to use load immediate D, 4A 6E. So it is enough to mention only the higher byte register in the instruction. No need to mention as DE. It is enough to mention D, because D will have the higher byte value and E will have the lower byte value. So in this data, what is the higher byte? 4A is the higher byte value. So lower byte value is 6E. So after executing this instruction, so the D register will have the value of 4A and L register will have the value of 6E. So do remember that these values will be stored in the register as a binary value. So for explanation, we are using a hexadecimal value for representing, but in the architecture it will be stored as a binary value. Not only in the architecture, in the memory also it will be stored as a binary values. The next instruction that we are going to see is move M, RS. If you want to move the value in the register to a memory location, you can use this instruction. So what will happen here is, for example, move M, A. So which means that the value in the accumulator will get stored in memory. So M represents what? It will represent the HL register pair. So what the processor will do? It will check the HL register pair value and consider this as memory, and the value in the accumulator will get stored in this memory location. So for example, before execution, consider accumulator is having the value of 25 and the memory location, what location we have used? 4648, 4649. So this will have before execution some value as 3A. So after execution, what will happen? The A will retain with the same value because it's performing a transfer only. Okay, fine. So that the memory location will be 4648 will be replaced with 25. So this 464A will be stored in HL register pair. Fine. Okay. So the next instruction that we are going to see is the vice versa of the previous instruction. So RD, M. So in the previous instruction, memory is used as a destination. So on this instruction, memory is used as a source. So for example, move B, M. So the HL value is 495A and A value is, sorry, not A value, B value. We have used B register. B value is 5C and the memory location 495A is having the value of 2C. So this is before execution. After execution, what will happen? So the value in B will be replaced with what? It will be replaced with 2C. Okay. So the HL value will be the same. We are not performing any operation with the memory. Okay, fine. So the B will be replaced with 2C and then the location 495A will have the same value 2C. So when the processor sees this instruction, what it will do is, first it will check the HL register pair. So look into the value, goes to that memory, see to the value stored in it, take that value and then transfer it to the register, P register, because B was mentioned in the instruction. The next instruction that we are going to see is LHLD address value. So I will take one example and I will explain it. LHLD 5500. So what L in the sense? It will load. So what load operation will do is, it will take some value from memory address to processor. Processor means some registers inside the processor. Here they have mentioned HL. So from memory location to HL register pair, which means that the value in the memory location will get stored in HL register pair. In LDA, what happened? The 8-bit data from memory is transferred to accumulator. But here a 16-bit data from the memory location will get stored in the accumulator. Okay, fine. So 16-bit data in the sense, so the higher bit data will be stored in H and lower bit data will be stored in L. So let us see how it operates. So we take this example LHLD 5500. What will happen if the process execute this? Means the value in 5500 will get stored in L register. Okay, fine. So the next value is 5501, which means the memory location plus 1 will get stored in H register. Okay, so let us see before execution. So the stack 5500, 5501, 5502. So this is having the value of 2A, 2C. Okay, so before execution, stack is having this value and HL register pair is having some other value, 4500. So after execution, what will happen? Okay, so after execution, this 5500 will get stored in L. This is the lower byte, no? This is L register and this is H register. The value in 5500 is stored in L register, and 5500 plus 1, which is nothing but 5501, will get stored in H register. Okay, so when you see the instruction, the address location mentioned in the instruction, okay, that will be incremented. So what will happen after execution? So 5500 value will get, this is 2C, which will be stored in L register 2C, and 5501 2A, which is stored in H register 2A. Okay, so load is nothing but you are loading the processor with the value from the memory. So okay, so what will happen? As we have mentioned 5500, the address mentioned will be stored, the value in the address stored, the value stored in the address mentioned in the instruction will go to L, that memory value plus 1, the value in that will be stored in H. The next instruction that we are going to see is SHLD. So what will happen here is the value in HL register pair will get stored in memory location. So this location will be mentioned in the instruction. So the value in the L will get stored in the memory address mentioned in the instruction, and H will be stored in memory address plus 1. So for example, take this instruction SHLD 5655. Okay, so what will happen before execution? HL register is having the value 2A65, and this will be your stack 5655, 5656. This would be your stack, and this might have some values 2626. So after execution, what will happen? So 5655, 5656. So as mentioned in the instruction, SHLD 5655. So what we have said, the value in L register will get stored in the memory location, that is 5656. The value in the L register is 65. So this will be stored in 5655, that is nothing but 65. So the value in the H will be stored in memory address plus 1, which is nothing but 5655 55 plus 1, which is 5656. So there 2a will be stored. Okay. So the store is nothing but the value from processor to memory location. So remaining data transfer instruction we will see in the next video lectures.